Have you ever looked up and noticed something missing? For decades, skies were filled with Trijets, airliners with two engines under the wings and a third on the tail. These were icons like the Boeing 727, Lockheed L-1011 TriStar, and McDonnell Douglas DC-10. Today they've all but vanished from passenger service. But here's the puzzle. Their four-engine cousins, the Quadjets, stuck around much longer. Why did three-engine planes disappear before four-engine ones? It seems counterintuitive. The answer is a fascinating mix of technology, economics, and engineering. How a perfect solution for one era became obsolete in the next. Let's unravel the mystery of the vanishing Trijet. To understand why Trijets vanished, we need to see why they thrived. In the 1960s, jet engines weren't as powerful or reliable as today's. Twin jets were limited by the 60-minute rule. They had to stay within an hour of an airport, restricting long-haul routes. Trijets, with their nuts, weren't bound by this rule. They could cross oceans and serve routes twin jets couldn't. They were more economical than massive quadjets, which were expensive to buy, fuel, and maintain. Airlines needed something in the middle, a plane with range and safety, but not the size or cost of a jumbo jet. The Trijet was the Goldilocks solution, just right for its time. But this perfect balance was built on the limitations of the era. Once those limits faded, so did the Trijet's advantage. The first nail in the Trijet's coffin was the jet engine itself. In the 1970s and 80s, engines became more powerful, efficient, and reliable. High-bypass turbofans changed everything, making long-haul flights possible with just two engines. This led to ETOPS regulations, allowing twin jets to fly far from diversion airports, erasing the Trijet's main advantage. Now, twin jets like the Boeing 767 and Airbus A330 could do everything a Trijet could, but cheaper. Even without ETOPS, new engines were so powerful that two could outperform three older ones. The Trijet's unique selling point evaporated almost overnight. Technology had moved on. As engines improved, the Trijet's third engine became a liability. That extra engine meant more weight, more fuel burn, and higher maintenance costs. Airlines now had a choice: two engines to buy, service, and fuel, or three. With twin jets able to fly the same routes, the Trijet's business case collapsed. It was too expensive to operate compared to twin jets, but couldn't match quadjets for size or range. The third engine, once a symbol of capability, became an anchor. Attempts to modernize the Trijet, like the MD-11, couldn't save it. Airlines moved on to more efficient twin jets. The Trijet was stuck in the middle, with nowhere left to go. If three engines were worse than two, why did four-engine planes last longer? The answer: scale. For decades, only four engines could lift the heaviest loads and fly the longest routes. The Boeing 747, for example, needed four engines to carry its massive payload across oceans. No twin jet could match its capacity or range for years. Quad jets dominated high-density and ultra-long-haul routes, protected by the limits of engine technology. They also excelled as cargo haulers, with huge fuselages, perfect for freight. The Trijet, being smaller, never had this advantage. Quad jets survived because their niche couldn't be filled by anything smaller, until much later. The Trijet's tail engine was an engineering headache. Mounting an engine high on the tail required heavy, complex structures and created aerodynamic challenges. The S-duct feeding air to the engine caused turbulence and reduced efficiency. Maintenance was harder. Servicing a tail engine was time-consuming and costly. The large tail structure added drag and weight, further hurting performance. In the past, these were acceptable trade-offs for range and safety, but as efficiency became king, these flaws stood out. The tail engine, once a defining feature, became a hidden weakness. By the 1990s, the Trijet's advantages were gone. ETOPS let twin jets fly long-haul routes, erasing the Trijet's main selling point. Quadjets still ruled the largest, longest routes. The Trijet was too big for short-haul, too small for ultra-long-haul, and too inefficient for everything else. Its design compromises, extra weight, drag, and maintenance, became unacceptable. Compared to sleek, efficient twin jets, the Trijet looked outdated. With no economic or performance edge left, its purpose vanished. The Trijet's era was over. The end for passenger Trijets was a quiet fade-out. Airlines retired DC-10s, L-1011s, and MD-11s in favor of new twin jets. Some Trijets found a second life as cargo planes, where their large fuselages were useful. Companies like FedEx and UPS flew them for years, but even in cargo, efficiency won out. As new twin-engine freighters arrived, Trijets were phased out. A few survive in military or specialized roles, like the KC-10 tanker or flying hospitals, but these are rare exceptions. The Trijets' mainstream era is over. Its disappearance was a logical result of relentless progress. So, why did the Trijet vanish before the Quadjet? The Trijet was a brilliant solution to a temporary problem, a bridge between early twin jets and giant quadjets. But as engines improved, twin jets took over its routes with better economics. The third engine became a burden, not a benefit. Quadjets survived longer because their size and range couldn't be matched, until technology finally caught up. The Trijet had no protected niche, so it disappeared first. Its story is a lesson in how progress can make even the best ideas obsolete. The next time you see a modern twin jet, remember the Trijet, the crucial stepping stone that made today's air travel possible.